Good evening. This is Kavipriya, Assistant Professor, EC Department. Today I am going to deliver a topic DC motor, construction and working of DC motor from the subject Basics of Electrical Engineering and Instrumentation. So first, what is a DC motor? So before getting into this DC motor, in general, DC machines are classified into two types. They are DC generator and DC motor. So DC generator is one which converts a mechanical energy into electrical energy, where DC motor is one which converts electrical energy into mechanical energy. And next is the construction of DC motor. So DC motor consists of yoke. It consists of poles consist of pole core and pole shoe, and field winding and armature, brushes, commutator, armature winding. So the important parts are yoke, field winding, pole, armature, commutator, brushes and gear. And first is the yoke. Yoke is one which acts as an outermost cover to the DC machine. So the outermost part of a DC machine is a yoke. So it provides an internal support to the components that is present over the inside. So it provides a support to the pole core, pole shoe, field winding and all. And next is a poles. So poles is a electromagnet. So field winding is wounded over the poles. So these poles will be producing the magnetic flux whenever the current passes through the field winding. So whenever the field winding is get excited, the poles will be producing the magnetic flux. So the magnetic flux is get produced by the field winding whenever the current is get passed over the field winding. And next is a field winding. So the coils that wound around the pole are called field coils. They are connected in series with each other to form the field winding. So whenever the current passes through the field winding, it will be producing the magnetic flux in the air gap between the pole and the armature. And next is the armature. So armature is a cylindrical drum. It is mounted on a shaft in which number of slots are provided. This number of conductors will be placed in the slots. All the conductors are interconnected to form the armature conductors. And armature conductors or number of conductors will be placed in a slots. All the conductors are interconnected to form the armature winding. And next is a commutator. So commutator is one which is cylindrical drum which is mounted on a shaft along with the armature core. So it collects a current from the armature conductor and it passes to the external load via brushes. So the field winding is one which produces a magnetic flux, and the magnetic flux reaches the armature, and the current from the armature core is passed to the external circuit through brushes. And commutator. So commutator is one which is rotating in nature. So we can't connect any external load directly to the commutator. So the current from the armature is passed on to the external load through the carbon brushes. So the carbon brushes are one which is get attached to the surface of the commutator by springs. And next is a working principle of DC motor. So the working principle of DC motor is that whenever a current carrying conductor is placed in a magnetic field, it will be experiencing a mechanical force. And because of this force, it will be start moving. Here the motor will be start rotating. So it is given by Fleming's left hand rule. So according to Fleming's left hand rule, whenever we stretch the first finger, second finger and thumb of our left hand mutually perpendicular to each other, the first finger will be representing the direction of the magnetic field, second finger will be representing the direction of a current, and thumb is one which represents the direction of the force that is experienced by the current carrying conductor. So the current carrying conductor is placed in a magnetic field, and because of that it will be experiencing the force and it will be start moving. That is the working principle behind the DC motor. So the current carrying conductor experiencing a force and it starts moving. So the force is given by BIL. So B is a magnetic flux density, I is a current, and L is a length of the conductor within the magnetic field. So when an armature winding is connected to the DC supply, electric current will be sets up in the winding. And the permanent magnets or field winding is one which provides a magnetic field. And the current carrying armature conductor experience a force due to magnetic field. The commutator is made segmented to achieve the unidirectional torque. So direction of force would have been reversed every time when the direction of movement of conductor is reversed in the magnetic field if this commutator is not segmented to achieve the unidirectional torque. So we have you have a yoke act as an outermost cover, and we have this poles inside the yoke. The winding that wounds over the pole, we call it as a field winding. So whenever the current passes over this field winding, it will be producing the magnetic flux. And we have this armature. So the magnetic flux is now directed towards the armature. And we have this armature. Armature has a number of conductors. The conductors are all interconnected to form the armature winding. So when armature winding is connected to the supply, electric current will set up in the winding, and the permanent magnets already has produces the magnetic field. So the current carrying armature conductor now experiences the force because of this magnetic field. So the current carrying conductor, when placed in the magnetic field, it will be experiencing the force. So these conductors will be start moving. And we have this commutator, and commutator is one which collects a current from the armature, and the current from the commutator cannot be directly passed on to the external loads because commutator is rotating in one, and the commutator is connected to the brushes. So with the help of a brushes, the current that is produced in the armature is passed over to the external circuit. So brushes is one which is get connected to the commutator through the brushes. So through the springs. This is the working principle and construction of a DC motor. Thank you.